we're in our second type of energy that we want to talk about, and this is potential energy, which if I was to write a symbol for it, I would write PE, but symbolically, it's written with the U. So earlier, as a very quick review, the work stored in motion was called, not was, is called the change in kinetic energy. The same thing happens here. The work stored in changing the position, and it could also be configuration, but changing the position of an object is called the change in potential energy. So this is categorically a different type of energy. And I'll give you a physical way of looking at it, and then we'll get into it lightly mathematically so that you could see how we could write it down. The two important types of potential energy are, one, spring potential energy, and two, gravitational. And so what we want to do here is that spring is visually easier to see than gravitational potential energy. And you'll find that gravitational potential energy can be quite abstract when you start to look at that. Therefore, I choose to start off with spring potential energy. And the way we write spring potential energy mathematically, we write a symbol U with the subscript of S. So now what we want to do here is that we want to rely heavily on what we did last time with kinetic energy, because energy is energy. How we deal with the work energy term is exactly the same. And here's what we find. That anytime work is done, it does not disappear, but reappears as stored work. And this stored work we define as the change in energy. So in this case, this change in energy is going to be the change in potential energy. So here we go. Suppose we have a spring block system. So I imagine that I have a block. And what I'm going to do here is that I'm going to compress this block. And this block is attached to a spring. And this spring, the rungs of the spring are compressed here. So what you're seeing here is that you want to think about what is actually happening. For starters here, what is my system? Well, it's actually the block. So when I think about the block, here's my system. What I'm going to do is that I'm going to apply an external force, and I'm going to say that this is the force of my hand that's actually applying a force on this block. And what I'm going to do here is that I'm going to displace this block right here. So what we're seeing here is that there's a couple of things that we should have a visualization here, is that no, we are not talking about the spring right now. We are talking about the work done by my hand. So the work done by my hand is external. And because it's external, what it does here is it increases the energy of the system. The work of the hand increases the energy of the system. So when we look at this picture-wise, we could say here is that there's some amount of energy in the block, right? There's some amount of energy in the block, and in this case, we call it U, and I'll call this U1. And what I'm going to do here is that I'm going to do some external work, and that external work then increases the energy of this system. You know what? Let's not call it U right now. Let's just call it E for right now, because I have to make some clarification. So this is something that we've been talking about. And you know what? I'm not going to say external. I'm going to say the work of my hand. So we're clear on how we're writing this. So the only thing that's meaningful here, again, is that this is the change in energy of the spring system. So once again, the increase in energy, delta E, is due to the work of my hand. What happens from the perspective of the spring? The spring also does work. So when you go back and you look at the spring, what you're seeing here is that I have a force of the spring that, according to Newton's third law, it is applying a force in the opposite direction of my hand. So when I say that the spring does work, it is negative work. And this becomes a really big deal when you start to think about this in the language of how we deal with this. And using some mathematics, it becomes really useful to actually, think about this in sort of like areas and integrals and stuff like that, but that's beyond the scope of this course. So, in other words, because of Newton's third law, the force of my hand must be equal to the negative force of the spring, and therefore, we could then say that we have positive work of my hand, but at the same time, we have negative work of the spring. In each situation, this energy represents an increase in stored work. Or in other words, we could also say that this is an increase in energy. So our goal is not to focus on the hand, it's to focus on the spring. So if we focus only on the spring, I still have to do some clarification before we move on here. We have to ask, how did the energy change? So the first thing that we should say is that if I look at the change in kinetic energy, we could come in here and we could say that this guy is 0. So the question is, if I ask here, why is the change in kinetic energy equal to 0? Well, the block starts and ends at rest. So if I take my block system here, let me draw this a little bit smaller, but you could imagine that I have my block right here, and now I'm going to push it against the spring here. And so what you're seeing here is that when I look at this thing here, I'm going to say that at this position 1, it starts off with the speed of 0. And then I'm going to compress the spring. And as I compress the spring, I'm going to keep compressing it till I can't compress it anymore. So therefore, its speed is also 0. So what this tells me here is that the change in kinetic energy, which is then 1/2 v2 squared minus 1/2 v1 squared, well, it starts off initially with the speed of 0, with the speed of 0, and it finishes with the speed of 0. Therefore, the change in kinetic energy must be 0. So what this concludes here is that there must be a new type of energy. So then we say that there must be a new type of energy. Right? There must be a new type of energy. And this is what we call potential energy. And what we're seeing here is that we can clearly see that this new type of energy only depends on changes in position. And that, by definition here, is then the change in potential energy. And symbolically, we write that with the delta U here. So we can say one more thing here. So from the work energy theorem, that only focuses on the spring, not my hand, but the spring, we then say that we need that automatic minus sign, and this is going to be the work of the spring. And that minus sign is always there because the force of the spring is always opposing the force of my hand. So as a consequence, this tells us that this quantity right here is actually a positive amount of work. And this is what we then define as the spring potential energy here. So this right here is, by definition, what we mean by potential energy. So one last thing here, and I want to take this picture with me. And I want to bring it back down here. So when I look at this guy, what does this thing actually tell me here? So what we know is that where is this potential energy stored? By looking at the spring, we can see here that if we look at the spring, you could see that the work done is stored in the spring compression. It's in the spring compression. So by looking at the spring, the energy is in the deformation of the spring. The fact that you're compressing and deforming the shape of the spring tells you that it has to be in the spring. So you can physically see that.